Good afternoon, everyone. Thank you for your attendance. Sorry I couldn't be there in person, but let me go ahead and get started here. As you can see, the title of this paper is Nuclear Electric Shipboard Power.
Hesham, just so you know, I think we see your presenter view, not the presentation itself.
Oh, let's see. It says that I'm screening. I mean, I'm sharing the screen right now. So
yeah, you are. I think it's just we can see we see the slides as opposed to the actual presentation. And maybe you have to switch on the monitor. Switch from automatic to another option.
Say again. Do it.
Top where it says automatic, you might want to switch that. Top where it says monitor, top center, a little to the right.
Okay, let's see. Okay. Like this. Is this okay?
Well, I mean, we can use it, but it's not the presentation view.
Oh, I'm trying to. I guess I haven't used it in a while, so I forgot how to. Go small. Okay, more.
Near the top of your screen where it says monitor. Towards the middle of this middle top.
Okay, it says.
Up there, yes. Do you see where it says automatic? Just to the right of that.
Oh, I'm sorry.
That's okay. If we can't change it, just continue in this way. That's fine.
All right. I'm sorry.
That's okay. Go ahead.
So nuclear electric shipboard power plant as a senior project. I guess as a disclaimer, the emphasis is probably going to be a little bit more on the educational aspect, although of course I'll also talk about the design aspects of this project. So as you may be aware, at the U.S. Merchant Marine Academy, we have the marine engineering programs. The students can be in systems. Also, another option is shipyard management versus what we call straight engine. And there are several areas of emphasis, including electrical, nuclear, naval architecture, and the capstone design project obviously is something that the students are supposed to do at their senior year in order to practice all these different topics that they've learned and to get involved in a team project. And usually there are in each group there will be seniors from different disciplines, and this particular one was this particular project was a few years ago, and it was actually there was support from the Office of Naval Research, and so just the basic information on the senior project. It's a 3-credit course, and usually in this particular case we had 4 teams, one for each of these areas. I was involved. I was involved with the electrical group. There was obviously faculty supervision and guidance in order to provide them with kind of help them along the way and supervise their work. We had weekly meetings, and of course the teams met on their own, and so that's fairly standard as far as capstone or senior projects. Just a little bit of background. We have the type of ship that was being considered here is the Navy auxiliary ships. One of the concepts that were considered is that these ships can also be used to supply power to the national grid during times of emergencies, like if there's a hurricane that knocked out the power to a large area, they can be used for that. There's also the concept, and also included the development of higher speed vessels, and Obviously, in this case, the advanced technology can be used to meet the design goals. And the design concept was that, again, to meet the need of a high-speed auxiliary ship, and in this case, to use a nuclear power plant to generate the power. Here we also considered the novel propulsion techniques or technologies that can achieve at least 40 knots, and also to provide 300 megawatt of power to the national grid, again at a domestic port in cases of emergencies and including things like hurricanes and things like that that can knock out the power for a large number of population. And so in this case, the propulsion was developed mostly with electric-driven water jets, and these high-speed power. So there was also the high-speed power steering and stopping were accomplished utilizing these what is referred to as rim-driven propulsor pods. And of course, in the paper, there's a little bit more details on this. And again, the maximum speed of this design concept was 40 knots. And also another consideration was that we should have major reduction in the ship displacement based on reducing large component weights and volumes associated with volume storage. Now, in terms of the electric power, in this case, we had this design concept of a nuclear power plant to generate the power, again, for the ship, as well as can be connected to the national grid during emergencies, and to obviously propel the vessel. In this case, the pressurized water reactor would produce steam, supplying one 300 megawatt steam generator that provides 13.8 kilovolt of electricity, and up to, again, 300 megawatt of power for the national grid through a connection to some type of a substation. And in that case, that would be, the substation would be designed for accepting the vessel power or voltage at that voltage level, 13.8, and then obviously it can be stepped up for the local grid, depending on what it is. And so in this case, we actually had some industry involvement. There were industry experts who visited the campus, and also the design team visited, a couple of locations, including at that time, it was still, working, the Indian Point, and so we had also these technical presentations by the technical experts. We had a visit to the Entergy and Long Island Power Authority, and so in terms of the again, since this was an educational process, just some pedagogical observations and conclusions. As I mentioned, the students in different teams at the beginning, or actually I didn't mention this earlier, but at the beginning there was, it wasn't easy to kind of integrate or, communicate effectively with other teams and other, between different areas. But that developed obviously as we continued with the project, and so again, one of the objectives of this type of course is to learn to work as a team and find value in what each team can offer the other. And so in this case, again, this in quotation found comfort and difference, and obviously the contribution of each team from different perspectives or different areas contributed to a useful and meaningful dialogue. And so this concept of, or the idea of interdisciplinary team also helps to in their training for teamwork and working with other teams to achieve a common goal. And And so again, this was one of the major advantages of this type of course, and it was, you know, a useful experience. And also, you know, the students obviously were engaged in what we would think of as self-directed learning, in addition to obviously the supervision of the faculty members. They obviously did quite a bit of research and on their own. And also, again, the involvement of industry and industry experts provided, you know, technical data and you know, practical information that was used in the in this process. And so I kind of kept it short, I guess, you know, but if you have any questions at this point, I'll be glad to answer any questions.
Any questions? Okay. Looks like we don't have any questions from the audience here.
All right.
See any in our chat? Yep, I think that's so. Thank you very much.
Okay. Thank you.